I'm CK. Tonight I pulled a kit out of my Mitch Electronics bag. It's a PWM generator, a pulse width with modifications generator, making a square wave with variable pulse width. Very useful if you're injecting signals into a guitar amp or another electrical circuit and following it through. So we'll put it together, take a look at the build guide, which for Mitch Electronics is generally pretty good with a great schematic and good simulator, and see how much we get out of it. And I hope you enjoy the video. Here's the bag. We'll pull up the build guide a bit later. Let's see what's inside. We've got a dip socket, LM358 IC. I know what that is. I can't remember it right now. Capacitor, few resistors, and a potentiometer. Red wire, blue wire, black wire, and the PCB. So it looks like it's relatively straightforward. Dump the parts out. Nothing left in the bag, but we want to keep it because it's got the QR code. Oh, by the way, you know, even if you don't buy these kits, you can go to Mitch Electronics website and just go through all the kits and look at the simulator and schematics and learn quite a bit, not without even buying the kits and playing with them. So what is an LM3? I know what an LM358 is. Come on thing, wake up. Here we are. Oh, they're op amps. I thought so. That's just a TI op amp. Did they give us? Oh, they gave us two of them. Okay. So we've got two 358 op amps. They're originally by TI, but these are from somebody who I don't recognize the logo or abbreviation. I don't know the manufacturers. A couple of sockets, a potentiometer, another potentiometer. I think they're both 100K. Probably amplitude and width. Then we've got some 100 nanofarad 104 caps, which are going to be decoupling caps for the ICs. And here are the resistors and a couple of pieces of wire, 4 pieces of wire. So we'll see. That's what it is. Looks pretty straightforward. We've got on the circuit board, which is just dandy, good quality. The 2 pots go here, the 2 ICs go here, capacitors here for decoupling, resistors. This looks like power in, VCC and ground, and this is ground and out. So that all looks pretty clear. So I'll get the solder iron heated up, I'll bring the build guide up, and we'll put this little guy together. I don't know how much power it takes. We'll find out when we get to the build guide, I'm sure. Brought up the build guide, and as I mentioned, it's got a great explanation of what it's going to be doing, creating a triangle wave and then a square wave and modifying the duty cycles and so on. Here's the schematic with the op amps providing the control you need, and here is again the simulator, and we can run it faster, which is too fast, and then we can change the frequency. Oops. And you can see the frequency change right there. We can change the pulse width modulation level, and that's what falls off there. This is the triangle wave that then becomes the square wave. Come on. It's a little hard to grab. Come on guys. There we go. Now I turned it completely off. And again, you can play with this completely and it shows you what it's doing. So you can play with it by yourself without even having the kit. And of course it's a relatively easy kit to put together, and I grabbed my little motor because pulse width controls are often used as, besides voltage controls, they're also used as motor speed controls, so that's what we'll be doing once we get it all done. Now we'll start putting things together. Now he just lists the socket first, but we're not going to do the sockets first. We're going to do the resistors first, because we generally like to do resistors first. we've got this one, where is it? Come on out, guy. Got this one 47K. You can see yellow, lavender, purple, whatever you want to call it. Then we've got a number of 100K resistors. So we'll start with the 47K resistor, which goes in R2. Slap that in there. See how the board takes solder, and as we anticipate that it'll do well, because Mitch Electronics generally has really good circuit boards. I say generally only because I haven't done all of them, but all the ones I have done are really good circuit boards. So that's that. Now we'll put the other 3 resistors on, so we will have a very short resistor time as I speed through this. That's the resistors. That one's a little up. I could fix that, but I'm not gonna. We're not doing beauty contests. So we'll put the sockets on now, and they have notches in the sockets that match up with the notches on the circuit board. So we can make sure they all go in correctly. And I will flip that over with the index card underneath it so both sockets are in place. And I don't have to worry too much about these lying flat because there's nothing higher than them on this board. So they're just going to lie flat as they go. So I'll just solder them on down. Straightforward enough. Now I'll put the capacitors on. And while I'm going to do that, capacitors on a paper strip for machine installation. But since we're not machines, we can't deal with it very well, so I just clip them out. I don't try and pull them out because I'll damage something or twist the wires around, the leads around, which is annoying. And they'll just go in the C1 through C3. Decoupling caps, which provide, capacitors provide a little bit of energy buffering and smoothing, and we put them near the ICs to make sure the power coming into the IC does not fluctuate too much. You can read more about decoupling caps. In fact, I would recommend you do, because every time, almost every time, you use an IC, you're going to put one or more decoupling caps on them, at least one for the power coming in. And again, you can trace the circuits and see what pins the decoupling cap is coming from. There's that. Now I think we'll put the 2 potentiometers on. Straightforward enough. Put them through, and I'm going to solder the middle leg on both of them without being too accurate right now, just to get them in place so they don't flop around while I'm trying to adjust them. There they are, they're little cattywampus. So I will heat that solder I just put on, get them right, take the soldering iron away, let the solder cool. There, it's all nice and pretty. Do the same with the other one. These may even be in the same line. They really are. Gosh, I normally am not that accurate. Now we've got some wires to put on. We use 2 black wires for our grounds. Let me get my Knipex wire strippers. Strip a little bit off each end. Oops. I'm not going to tin them because I'm lazy. Put one through the... Now I should have tinned them because it just cat whiskered on me. Of course, my cats just heard that inside and said, "We want something to eat," but I'll have to wait a little bit. Now the red and the green wire. I'm going to use red for the input power and blue for the output pulse. Come on. Don't know why my insulation's sticking tonight. So this is out. When you see me brushing stuff off the workbench, I vacuum the floor after each kit because I do tend to make a mess. And I'm also going to do this. I'm going to, as I said, I'm going to use this little motor as the test. Well, I tried to get the motor working. I think I may have burned it out the last time I used it. I ran it really hard up to 24 volts, and I think it may not have recovered from that. So what I'm going to do instead, so I was going to try and use the motor, but I couldn't because it wouldn't spin. I think I burned it out the last time, like a month or so ago. I took it up to like 24 volts and for a while and burn out some other components. Might have damaged the motor. So instead I'm going to use a little LED because you can use it for dimming and lighting something as well as controlling a motor or creating an oscillator. If you look at some of my other videos on Eurorack stuff, you'll see a lot of square wave oscillators out there, and this is the way you can get to one using pulse width modulation. So instead I've got a little LED here, and I'll bring the scope up. If it's not already up, I never know how I'm going to edit this. Now we'll increase the pulse width, and I've got my little power supply at about 5 volts. So there you go. We've got the pulses coming up. Let me set this to roll. Maybe I get it better. There we go. We've got a nice little march of square wave pulses, and the LED is lit up a little bit, as you can see here. Now I'll increase the width of the pulses, which provides more continuous energy. You can see there's a very slight drop-off, a very inconsequential time of drop-off. So the LED is brighter. I can take it all the way up so it's fully passing the 5 volts right on through, and the LED is very bright. I'll drop it back down. Now I'll change the frequency. And the pulse. And you can see as I turn the frequency down, we can dim it also. And it went way, way down. So that's what it does. If we, again, decrease the pulse width, so less electricity is getting passed on, and the LED dims down, and it dims back, and starts back up. So that's a pretty good demonstration of what pulse width modulation and pulse width signals are. This actually with the triangle wave generator, flattening it out to be square wave, is a pretty good square wave. There's not much overshoot, there's no undershoot, so it's a pretty good kit, and you can learn a lot from it. And as always, I hope you enjoyed the video.